Are you questioning if your pocket screws are strong enough? Should you skip the pockets and just screw? Is your pocket screw joinery more cracked than Windows Vista in 2007? Well, stick around because I have some answers to these burning pocket screw questions and more that are backed up by cold, hard facts. Besides the fact that pocket screws can be hidden easily in some cases, pocket screws are also supposedly stronger than simply using some construction screws from the outside. The reasoning behind this is quite simple, and to demonstrate, I have some hilariously large screws and some illegal Canadian plastic straws. The straws represent the grain or the fibers within the wood, and the screws, well, they represent screws. The fibers run along the length of the board, and each fiber is relatively strong from severing in half. However, the bond between the fibers isn't as strong as the fibers themselves. When you use a pocket screw, you're supposed to drive it into the face or the edge of a board, but not the end of a board. As the threads enter the grain this way, the fibers wrap around the threads of the screw without severing, and it creates a mechanical lock that prevents the screw from pulling out as easily. When simply screwing one board to another from the outside and into the end grain of another, the fibers are either being pushed apart or actually severing between each thread of the screw, resulting in a much weaker connection between the screw and the wood. Anyways, this is all in theory, and I'm not in the business of hypotheticals because I learn better by seeing and doing. So let's give this a test, shall we? Now, like all of my joint testing, this is fairly rough science and definitely not thorough enough, but it does give us a decent idea since I'm taking the average of 5 joints per test. There are other orientations that I can stress the joint in, and this also doesn't account for longevity, yada yada yada. It's not perfect. The pocket screw turns out to be over 20% stronger on average in comparison to the construction screw put in from the outside and into the end grain of the other. And to compare apples to apples, both screws are 1.25" number 8 screws. So it seems like, yes, this theory holds true that pocket screws are in fact stronger. But when screwing from the outside in, you have the opportunity to use a much longer screw, and typically with 3/4 inch material like I'm using here, I would at minimum use 1.5 inch screw. So how about we exaggerate it more and see if there's anything to be gained from using a 2-inch screw? By the way, I'm not using any glue on these tests because each joint would have the exact same amount of glue on it, so I'm eliminating a variable by not including it. But don't worry, I have some burning questions about the effectiveness of pocket screws and glue that I want to answer later. Anyways, back to the 2-inch screw, which scored a staggering 2 times stronger than the pocket screw. And that is a considerable difference. So what does all this mean? In cases where the outside of the joint does matter, then pocket screws still make sense because they truly do excel in the scenario where you don't want to see any fastener from the outside. There are options to hide regular screws like making or buying hardwood plugs, but this option is obviously not invisible. The main point that I'm trying to get across is that I see a lot of people on social media use pocket screws in situations where construction screws from the outside won't actually be seen in the end. It's clear that longer construction screws are stronger than pocket screws and are quite obviously faster too. So stop making life harder and simply screw it together when the situation is right. This is all fine and dandy when it comes to solid wood, but when it comes to plywood, does this still hold true? You see, plywood is made up of layers of thin wood veneers, and the grain direction alternates 90 degrees on each layer to create a more stable product. From the pocket screw's perspective, the grain of the mating piece hasn't really changed much since it's all still face grain again. But when using a regular construction screw, driving it into the edge of plywood, it's no longer just end grain like in solid wood, but now it's kind of half end grain and half face grain. Does this mean that the regular screw of the same size might actually be stronger than a pocket screw? Just like the solid wood samples, the core of the plywood I used was poplar, and they were all the exact same size with the exact same screw spacing. Immediately, the first thing I noticed was how much more consistent the results were in comparison to the solid wood samples, which definitely had a higher deviation. Since plywood is a man-made product, it's no surprise that the results are much more uniform. The 1.25" pocket screw took almost exactly the same amount of force on average to break in the plywood as it did in the solid wood, which is to be expected. The 1.25" construction screw, on the other hand, was over 30% stronger in the plywood as it was in the solid wood, and over 5% stronger in the same size pocket screw. The 2" construction screw, on the other hand, scored very similarly in plywood as it did in solid wood, and I think it's because it was the head of the screw that failed rather than the threads in the mating piece. So even more so than solid wood, in plywood it makes more sense to use longer construction screws from the outside rather than pocket screws when you don't need a hidden fastener. It's also quite common to use pocket screws to construct boxes, which can be for drawers or cabinets or maybe cases, but when making a drawer box, you would typically place the pocket screws on the outside where they'll eventually be hidden by a drawer front. Good job! This is the correct orientation for a pocket screw when screwing two boards together like this. However, sometimes you might find yourself in a pickle where placing the pocket screws on the outside of a case or a cabinet might be very unsightly in the end. So, you consider the ramifications of putting the pocket holes on the inside of the corner where you shouldn't. Will it explode? Unsurprisingly, the correct way is indeed a lot stronger. 65% stronger, in fact. So, this is definitely a no-no if you can help it. If having pocket screws or construction screws on the outside isn't going to work aesthetically, then you'll have to look into other joinery options. Luckily for you, I have a whole video on testing these types of joints, and you can go watch it after you watch this one to the very end. I'll know if you don't. Hey, it's now winter time and our shops are getting kind of cold. So if you want to focus on doing your best woodwork and not your numb fingertips, then perhaps it's time to upgrade your heater to the Drio wall-hung smart electric space heater. Now, I already have a mini split heat pump in my shop, but they're at least 15 times the cost of the Drio electric space heater. Mini splits are complicated to install, which either means you have to spend a lot of time doing it and buying special tools, or having to hire a professional to install. But the Drio mounts very easily on the wall using only 4 screws, and they send a template with it to make the install process even easier. And because it's an electric space heater, you don't need to worry about complicated line set installations like with mini splits. All you need to do is plug the Drio into a standard 15 amp 120 volt outlet and turn it on. The wall mount design is much more convenient for our shops rather than tripping over one of those little portable units. The remote control makes switching between eco modes and set temperatures easy, or you can control the heater from your phone using the Drio app or voice control using Alexa or Google Home. This means you can preheat your shop before you head out here, or you can set a schedule or temperature drop reminders, and there's also this cool anti-freezing function too. When I turn it on, I can feel the heat come out within seconds, which surprised the heck out of me because usually with electric space heaters, they tend to take quite a while to heat up, but not the Drio. And its 120 degree oscillating louver really spreads the heat around, so it really feels like it heats up the whole shop quite thoroughly and quite quickly. Drio's Christmas campaign is going on right now, so check out the product links in the description and get your workshop or your garage or any other room warm this winter. An annoying part of using pocket screws near the end of the board, like when making one of these joints for boxes, is that they occasionally like to split the mating piece as you're screwing them together. This doesn't happen every time and definitely depends on what type of wood you're using, because it happens to me more often in harder woods and in MDF. Now, there's a couple ways to prevent this splitting from happening, but they all add more time to the process of making pocket holes, which, to me, defeats one of the main advantages of pocket holes: speed. Now, I'll get to those preventative measures in a moment, but I want to point out one way the manufacturers are trying to prevent splitting. See this gouge in the side of the threads here? This creates a cutting edge that essentially taps the threads for the screw as you're driving it in. You might think this sounds reasonable. It's kind of like when a machinist taps threads into metal, right? Well, maybe in theory, but in my mind, there is a distinct difference. When using a metal tap, the machinist is constantly reversing direction to clear away the chips. Yet when woodworkers are driving pocket screws, we're simply driving them full send all the way home in one go. What's the big deal? Well, the screw isn't removing any wood as it's driven in. And if it's not removing any wood, then the screw is simply acting like a wedge, and much like splitting firewood with an axe, a wedge is going to want to split the wood. Specifically for harder woods, there are fine thread screws available from Craig. And I believe the thought behind these is that the major diameter is a bit smaller on the fine screws in comparison to the coarse screws, thereby making it less susceptible to splitting the wood. They make up the smaller diameter by adding more and therefore finer threads to get the same holding power as the larger diameter coarse threads. So does this actually help prevent splitting? Well, I drove 20 coarse screws into hard maple, which is a very susceptible species for splitting, and 11 out of 20 of them cracked. And then I drove 20 fine thread screws into maple, and 4 out of 20 of them cracked. So clearly, they do work. A bit. I don't know about you, but I still don't think a crack in 20% of my screws is a good look. The only way that I found to completely eliminate the chance of a crack in your pocket screw joint is to literally pre-drill the mating piece. Once it's clamped together, take a hilariously long 7/64 inch drill bit and drill some pilot holes through the already drilled pocket holes. You can now see how this makes a seemingly quick joint not so quick if we want to guarantee success. But it does work. I sent another 20 coarse thread screws through maple, but this time each one was pre-drilled and none of them cracked. If you're using something softer like fir, pine, poplar, or maybe even cherry, and you're making this type of box corner with pocket holes, you might need to pre-drill. But anything harder in this scenario, then I would definitely pick yourself up one of these 6-inch long pilot bits, and I'll leave a link in the description for this one. I've done all these strength tests without glue so far to take out any variables that applying glue might have. But I always use glue with pocket screws, unless I really truly think that I'll need to take something apart one day, which is usually shop furniture, and more often than not, I don't end up taking it apart anyways. After performing a whole bunch of different strength testing, I've shown in other videos how simple joints with glue can be quite strong, even the lowly butt joint. So, do any of these rules and subtleties of pocket hole screws really matter if the glue is potentially way stronger than screws? Adding glue to the pocket screw joint increased its average strength from 88 pounds to 174 pounds, which is twice as strong. So clearly we should always be using pocket screws with glue when possible. Now, I was convinced beforehand that the lowly glued butt joint without pocket screws wasn't going to be much different than with pocket screws, but I was definitely mistaken. The regular butt joint without glue only averaged at 98 pounds, which is quite a bit less than with pocket screws. Furthermore, the butt joint broke quite suddenly, whereas the pocket screw joint had a much more gradual failure and would likely stand up to more abuse because of this. So yeah, pocket screws and glue are significantly better than only glue. However, without testing it, I would imagine that long construction screws from the outside with glue would be even stronger again. To recap, it's my opinion, which was developed through the findings from my not so thorough testing, that you should only use pocket screws when you need a hidden fastener. Otherwise, just use regular screws from the outside when you don't. You shouldn't put them on the inside corner on a joint like this, and then if you're having trouble cracking, then pre-drill holes. And you should always use glue with pocket screws when possible. I'm not totally against pocket screws. I do think that they are slightly overused. And with so many other joinery options out there, there's always something new to learn so we can become better and more versatile woodworkers. Now, go watch this video. It's a good one. There, right there.